Hello guys, this is Minh and today I will talk about my final project, which is implement convolutional neural network in MATLAB. So a quick review about CNN. This one is a very effective type of neural network for image recognition. The difference between CNN and FNN is the structure. In CNN we also use the kernel, convolution and pooling layers, as well also the fully connected layers. For the forward propagation, we will use a kernel to slide through all the location of the image and then extract the new useful features. It's called feature maps. So in this example, I use 32 kernels to slide through the image of 28 by 28. The size of the filter is 5 by 5, the stride 1, so my output will be 24 by 24 by 32. And after that I use the ReLU as the activation function. In MATLAB you can also use the conv tool to do the convolution, but remember to flip your weights before you do that. And here we come for the pooling layer. The main purpose of pooling is to reduce the size of the convolution layer. So in here, for example, we have like a 4 by 4 matrix, and after the pooling we will reduce it to a 2 by 2 matrix. This is also called undersampling. So, and for the last layer, which is fully connected layer, the pooling layer will be flattened into just one dimension vector, and then it will be connected to the other final layers. In my example, the input is 24 by 24 by 32, and after the pooling my input is 12 by 12 by 32. And for the first layer of the fully connected layers, the output is 4068 neurons. So now we go to the backpropagation. For the fully connected layers, we would do the same that we did in the feed-forward neural network. In here we have the formula of it. We will first calculate the cost and delta and then the gradient. But how after that? How should we calculate the gradient and the delta of pooling and convolution layer? So after the backpropagation of the fully connected layers, the first delta matrix we have the size of 4068. The first thing we want to do is to reshape it into its original shape. So in here I reshape the delta matrix into 12 by 12 by 32 volume. And after that we will do oversampling to make a gradient matrix of the same size with the convolution layer. So after the oversam, I got a matrix of 24 by 24 by 32. So now what we're gonna do is to use this gradient matrix to calculate the new kernel. So the backpropagation of a CNN is also convolution. So in here we have the gradients of at convolution. So we use it to slide to the input feature maps, and then we will get the new kernel. So in this example, I use the convolution of the input feature maps and the gradient matrix, and the output will be 5 by 5 by 32 kernels. The result I got is about 65 to 7% of MNIST with 10 epochs, the batch size of 5000. However, this result is pretty poor, so I would love to improve it in the future. I have some notes that I think is important, that you should flip the kernel before convol in MATLAB, because the structure of that function if you flip your matrix before convol. And also you have to take care about the matrix transformation at each reshape, because like sometimes your volume will be flipped. And also I have reference are in the report. For some ideas of enhancement, I would love to add a visualization and add the momentum as customizable parameters like custom filter, stride, or number of convolution layer and pooling layer. And also I would love to test on different dataset. Thank you for watching.